Orchestrating dependency containers requires choosing between Docker Compose or application-driven orchestration via test containers. Because Docker Compose relies on static configuration files, managing dynamic port mappings to avoid networking conflicts during concurrent CI pipeline executions can be highly complex. You are also forced to rely on arbitrary external shell scripts to verify container readiness. Test containers resolves these limitations by moving container orchestration directly into your test code framework. It natively handles random dynamic port allocation, preventing network conflicts. It uses programmatic wait strategies, meaning your code explicitly waits for a specific log, like database system is ready, before executing a single test. Finally, it automatically cleans up all resources using the background Ryuk sidecar container, even if the CI suite crashes. The architectural best practice for optimizing execution speed with test containers is the Singleton Container Pattern. Under this model, a single instance of your service stub, database, or WireMock container initializes exactly once at the start of the entire test session, rather than rebooting per test file or per test. This allows you to bypass the severe compute and memory constraints of standard CI nodes. Furthermore, by enabling the test containers reuse feature in your local environment, the singleton stays alive between test runs, giving you the speed of Docker Compose locally while maintaining pristine ephemeral isolation in CI. However, running a single session scoped container creates a massive architectural challenge if your test framework executes individual tests asynchronously in parallel. If test A and test B run concurrently against the same shared database container, physical data isolation is impossible. You cannot truncate tables between tests because test A will delete test B's data mid-execution. Consider a scenario where multiple tests are inserting users simultaneously. If your test creates a user and then calls a list endpoint, it will suddenly receive users created by other parallel threads, causing unpredictable assertion failures. To solve this, you must shift from physical isolation to logical data isolation. Every single test execution must generate a unique tracking identifier, such as a UUID, at runtime. When the test inserts data, that UUID is injected into the payload. When your test calls the list endpoint, you never assert on the total count of the database. Instead, your test filters the API response for its specific UUID, completely ignoring the noise generated by parallel test threads. The data overlaps in the database, but the assertions remain strictly isolated. Another good idea can be isolating data per session with specific test UUID. To scale this architecture, implement a resource pool pattern using Worker-to-Environment Affinity. If your CI runner supports many parallel workers, simply assign one dedicated, permanent infrastructure stack to each worker process for the entire duration of the test run. By using the worker ID available in your test framework, like the worker index in pytest-x-dist, you pin worker 1 to environment 1 and worker 2 to environment 2. This eliminates all synchronization overhead. There is no contention, no lock management, and no purge bottlenecks because each worker is the exclusive owner of its infrastructure. Each worker runs its queue of test files sequentially, resetting its own local database state between files. To keep your footprint minimal and avoid the OOM killer, you must be watching your resources. Use lightweight Alpine-based images for your infrastructure and replace resource-heavy legacy Kafka with Redpanda, a high performance. By combining dedicated worker affinity with memory-optimized images, you ensure your CI gate remains deterministic, lightning fast, and completely crash-proof without going out of memory. To summarize, implement the session-scoped singleton pattern with test containers to maximize velocity. Use Alpine images and Redpanda to keep your memory footprint within strict limits. Enforce logical data isolation using unique UUID namespacing and pin dedicated infrastructure stacks to individual test workers to achieve perfect, collision-free parallelism. Thank you for watching. Please subscribe to the channel and leave a like.